In 1912, French chemist Louis-Camille Maillard attempted to reproduce biological protein synthesis. Instead, he discovered the most important chemical reaction in the culinary world. It is the reason a seared steak tastes different than boiled meat, and why toast tastes different than bread. It is not simply burning, it is a complex cascade of chemical rearrangement known as non-enzymatic browning. The Maillard reaction requires three specific variables: a reducing sugar, an amino acid, and thermal energy. When the surface temperature of food exceeds 140 degrees, the carbonyl group of the sugar reacts with the amino group of the amino acid. This releases a water molecule and forms an unstable intermediate structure known as a Schiff base. The Schiff base undergoes a reorganization of its atoms to form a more stable structure called an Amadori product, or a Haynes product. At this stage, the food has not yet turned brown, and the flavor has not significantly changed. This is the silent phase of the reaction, where the chemical potential energy is building. As heat continues to be applied, the Amadori products degrade. This is where the reaction branches into hundreds of different pathways, producing thousands of new flavor and aroma compounds. Furanones generate the sweet, caramel-like notes. Pyrazines create the savory, roasted flavors found in coffee and seared meat. Theophanies provide the meaty, roasted qualities. These new molecules are responsible for the umami depth that boiled food lacks. Simultaneously, polymers called melanoidins are formed, which are the brown pigments responsible for the visual crust. Water is the enemy of the Maillard reaction. Since the Maillard reaction requires temperatures above 140 degrees to proceed rapidly, any surface moisture on the food acts as a thermal barrier. This is why patting meat dry is not a stylistic choice, but a chemical necessity to remove the thermal buffer. While the Maillard reaction creates flavor, pushing the reaction too far can produce a byproduct called acrylamide. This occurs when the amino acid asparagine reacts with reducing sugars at high temperatures. Acrylamide is classified as a probable human carcinogen. This creates a chemical sweet spot. You want enough heat to create pyrazines, but not so much heat or time that you accumulate acrylamide. The Maillard reaction is the manipulation of heat to break molecular bonds and forge new ones, turning raw biological matter into a sensory experience.